Summers at the R.W. Smith & Company, here to do training on the controlled environment. This is you guys, I get a dime a ton fast when these things out, so you got that on tape, right? Go show my boss. Who we talk to? You guys facilities guys or users? Or?
Central planning.
Okay, okay, so we're talking to guys who are going to have to work with this thing. Okay, good, that's what I like. I'm not going to teach you a lot about refrigeration that you probably don't already know. Just a little bit about how this thing works and some of the controls. You guys probably haven't seen a whole lot of touchscreen interface on controlled environments. It's something we've been doing for about 109 years now. The cold room itself in construction is very typical. It's 4 inches of urethane foam, aluminum on both sides, and no wood in between. There's no framing members, nothing to actually transfer heat from inside to outside. The doors, construction of the doors are FRP, both the door frame and the door. That gives you, that plastic gives you your thermal separation between the inside and the outside temperatures. In addition, on the cold rooms we put there's a heater around the entire perimeter, 3 sides, with a magnetic gasket, and that heater passes across the bottom as well. And you'll notice there's a double wiper on the door. The purpose of that double wiper is to trap the heat from that heater, so that heater sits in the proper place underneath it, traps the heat, so you don't have condensation accumulation underneath the door. The door is lockable, but it doesn't latch, so there's nothing to actually stop it. If you happen to have the key and lock it, get locked in, you can see it's as simple as overcoming the lockdown. Nothing difficult about it. In addition to heating the door frame itself, the window is heated, the frame of the window. Power that gets to that from here. By the way, if something doesn't make sense, I talk too fast, I start Chinese, just stop me and ask me. We'll better cover questions when you have them later on. The room, let's come on in here. Just to finish the thought on the panels themselves, they're all tongue and groove, but it's all soft, what's called soft nose tongue and groove, so it's all foam. You got 100% foam. This entire environment is 100% foam. As if memory serves me, the floors are 2 inches thick, the walls are 4 inches. You see we have a center ceiling mount coil. It's 2-way, so it draws in the bottom and blows out both ways. The ceiling is put in there for a couple of reasons. It helps with fluid air distribution. You don't have a direct airflow in one spot. Plus it softens the light a little bit. It just gives it more of a laboratory feel. Those panels can pop right out. They're not a big deal. The most important thing up here is the fact that you have electrical on one end and refrigeration on the other, so you can literally just pop in either side of that coil. Refrigeration this side, electrical this side. And the most important thing to know, my flashlight doesn't fail me here. You notice the service switch is right here. Just a toggle switch. We make it nice and big so people can see it. That has a dual function. It not only kills power to the fans, but it also, it's a 2-pole. It says the low voltage back to the controls. It tells us that somebody's turned the fans off. And we shut the entire system down that way via controls. We log it and tell the world that somebody shut the fans off, and also turn off the audible alarm. So if it goes in a high temp, you're not going to have it, which is obviously going to be the time. You're not going to have an audible alarm. So if you want to come in and do any maintenance or service, if you shut that switch off, it does a soft shutdown. You can do what you want without having to deal with the alarms. There's a personal emergency switch in here, and we've got labels that'll be here in a little while, actually. The purpose of the personal emergency is just that if anybody happens to come overcome by something, falls down, can't get up, whatever, they would reach down and slap that. We shut the refrigeration off, turn the lights on, energize this guy up here and this guy that you can hear, and have a little thing here that tells people you ought to check inside, move the body out of the way, and reset the button. You're a stiff punch. That always gets it. Reset it resets everything. Okay. Somebody's going to call one day and say, I don't know what happened, but the thing's just going nuts. And you're just going to tell them, is it, the little light above? The only time this works is with the personal emergency. So if little light, the strobe above is going nuts, just tell them reach inside, latch side of the door, and reset that switch. Any questions? I can't be that clear.
Compressor up there.
Compressor's up there.
That's the easiest access right there.
The easiest one we found. Yeah, there's walls on 3 sides. This is about the easiest to get up to. I'm 57 years old. I don't have too many problems yet. We'll pop up. We have a ladder. We'll pop up. Take a quick look at it.
Its own water-cooled condenser.
Yeah.
Is this tied into the BMS system?
It is not. It can be. We'll cover that in a second. It can be tied into the BMS system, but we haven't seen the low voltage cables come down to it. So we'll show you if you want to. We've actually left the pull cord in there, so you can, if there's cables available or you pull cables to it, you can literally just pull it right down.
So we can get a contact closure maybe or something like that. If
You have
it's too
a
large.
couple of there. Yeah. 3 hinges. If you'll notice, as the cam rise, we've got a little bit more friction out here than we're accustomed to. So it may take a little bit of effort to open that because of that bottom sweeper. But the door actually opens or raises as it opens. And the purpose of that is so if there's anything on the floor that would stop it from opening, it's supposed to rise above it. Once we get down there, it's the point it'll self-close. This little device here, its whole purpose in life is to make sure that the door completely closes. The magnetic gasket itself will get a good attraction with it without, but you want to make sure it closes. No questions? No.
What is the refrigerant in there?
It's 404.
404.
It's the most, with Copeland and most manufacturers, it's the most supported gas out there. All the rest of them have a few compressors here and a few boils there. For the most part, 404 is the most supported gas.
What is the temperature of that room? What's the set point to maintain?
Well, I think it was 4 degrees is what they were looking for, so that's what we've set it up for. But it'll do anything from about 2 to 10. Pretty common. Okay. The refrigeration, glad you've broken us into that portion of it. The refrigeration is a hot gas bypass. So what we do is actually introduce hot gas in front of the expansion valve. And we do that so it's cooled before it reaches the compressor. Which it's just what it's doing literally is not heating the room, it's raising the suction pressure. And that's what, it's a Boyle's law, raise suction pressure, you raise the temperature of the room, or raise the temperature that you're actually putting out, which inevitably raises the temperature of the room. And that's how we attempt to maintain that 4 degrees Celsius. With a water-cooled system like this, you should be able to hit 4 degrees. There's a valve. We're going to cover the valve first. Downstream of the solenoid valve that controls the hot gas bypass. There's an ADRC, just a Sporlan ADRC. You guys probably have 100 of them in water cooling plants. And if it's set up properly, you can maintain 4 degrees C with both the liquid and the hot gas operating. The controls will tend to, if you have a low temperature excursion, a couple tenths of a degree, or depending upon the way you've set it up, it'll take out either the liquid or the hot gas solenoid to keep you within range. But when it's set up properly, both the hot gas and liquid are operating all the time. You have no problems. Does anybody want to get up there real quick and take a quick peek?
Yeah.
You got flashlights? Compressor, a helical condenser, hot gas. The water rig valve is, we put them on the outlet side. Probably we put them on the inlet side on chill water. They sweat, and there's 2 or 3 different metals in there. Next thing you know, they corrode like crazy. We put it on the outlet side, it looks like that for 20 years. But we have service, so if you ever need to take it off, you take the service valve off very easily. Just so you know it, there's a straighter valve in here and a straighter depressant in here. So if you had to replace that, you just take it off with very little gas loss. You don't have to worry about pumping it down or evacuating the system somehow. That's all taken care of for you. We talked about the ADRC, the hot gas bypass valve. So the hot gas is basically directed right off the compressor. We have a service valve here, a ball valve, across the solenoid, and then set down to in front of the expansion valve. Your liquid line solenoid, same situation. One thing here to note is this little guy right here. Little Mars switch. It's normally, I believe it's normally open. It doesn't really matter. It's tied to the control. What happens is if you lose cooling water, which is one of the problems we had a lot in the early days, instead of letting the high pressure switch take care of it, when we get to 275 pounds, by the way, we set the head pressure up between 190 and 200 on once you get to 275, which is not high pressure, but we know we don't have cooling water any longer, we kill the solenoids and pump the system down and kill the fans as well. That way we maintain temperature as much as we can. Because it's going programmable logic, we can actually log that, alarm, tell the world, hey, somebody's lost cooling water, so you guys will know it before it actually becomes a high temperature issue. Okay. Resets, so it'll go off at 275, and it resets at 190. So you can lose water 15 or 20 minutes, comes back on, it'll reset, except for the fact that it will be logged on the log. You'll know it'll be the wiser.
This is going down to that panel now.
Yeah, it goes down our control. Right? It goes down our control.
Is there anything on the low side?
No. No. No, if it's out of gas, the best way to find out is when you see that. Any questions?
Pretty neat system.
Yep, very key. The way these things are set up with a hot gas bypass running all the time, they're not starting and stopping all. It should last a long time. I've replaced very few compressors.
Where's the isolation valves for this? Is there any?
One here, the other one should be back there.
Oh, that's just the spring there.
Oh, that's just a drain. Oh, that's a drain off the, yeah, you know what? They're right there. Right next to you, right to the left of you. If you look up just a little bit, right there. Yeah. I remember seeing them there.
So that's just an open close, that's not variable, doesn't allow a variable amount of water through.
Oh, it does.
Does it?
Yeah, it will basically maintain head pressure at a constant, whatever you set up on. The last time we set up between 190 and 195.
Okay.
It'll be perfectly constant.
Pretty neat. That does have a low pressure cutout.
Yes. Yeah. The low pressure side here, and then the high pressure side set for about 325. What you don't want to do is stress your compressor by taking it too high, which is why we go to this point. Plus, it'll just go back and forth. All right. We have the operator interface, and then a service disconnect, and then a barrel switch. These things actually lock with a barrel switch, barrel key. We'll get you the barrel key for this. These are non-defeatable, so to open it up, you literally have to turn it off. NFPA tells us we have to do that. Also, you have the annunciator, which you guys are very familiar with now. We have power comes in. It's a separate source of power than the compressor. It has its own source. Power comes in and goes across that service disconnect, and then we distribute it from there. We have four breakers in it. The one thing I failed to mention earlier was the receptacles inside the room are actually fed from one of these breakers. I think it's CB3, but it's on the diagram. You can't miss it. So if there's a problem with everything's working fine, but you have a problem with the receptacles inside. And by the way, we have labels coming out to tell you that as well. They'll be able to tell you as well. Check inside the control console. One of them's for the fans, one of them's for the lights, one of them's for the receptacles, and this bottom one here, you'll notice the red wire as opposed to the black. That's our 101. 101 is control high voltage. Anything that's in red done by the factory, installed factory, originates from that 101. That's just kind of important to understand. In our wiring configuration, red 101 is control voltage. When I say high voltage, it's 120 volts. Anything in blue is low voltage, either 24 VDC that originates from here, or your RTDs, your temperature sensors. The yellow, NFPA, UL both say if you don't know what the voltage is, you have to make it yellow. In this case, 501 is one CR1, and 502 and 503 is CR2. And those are your two alarm outputs. So to your point, if you wanted to bring BMS system in here, you'd come in and you'd connect to those two. They are single pole double throw relay. Single pole double throw relays. Right now they're set up on in the controller is normally opened, but we run our relays, our alarm relays, normally energized. So as long as there's no problem, they are energized, and they de-energize. So you can actually change the polarity of them if you want to, just by moving this wire down.
Okay.
But for right now, you'll have a normally closed and normal operations. It'll open if something happens. We do that because if you lose power, obviously your alarms aren't going to tell you anything. So if you lose power, it'll switch the state of the relay, and you have a change in things. We talked about the RTDs. We should get into that real quickly. We have 2 RTDs in the room. There's one directly in front of the room. I think one installed inside the coil itself. So what
is the RTD?
The resistive temperature device. It's a fancy name for a little resistor, platinum resistor that tells you what the temperature is. And they're kind of the industry standard. It's a 100 ohm RTD. And just little 3-inch things, little encapsulated temperature sensors. One directly on the other side of the wall here, and then there's one inside the coil. So what we're getting essentially is we're getting downstream temperature directly off the coil, and return temperature because it's in the cavity of the coil itself. It's getting the air that's coming back into it. And what we do is in the control console, or in the controls, the programmable control logic, we actually average those 2 sensors. The problem's always been, where do you put a sensor? There's no one good place to put it. So we take both return and supply air, average the 2, and we generally get a very good understanding of what the temperature of that room is. Much better than just having one sensor. If you lose one of your sensors, it will tell you on the system status line. It'll tell you that you've lost a sensor. We'll cover that a little better. It'll tell you that you've lost one, but we don't consider that a critical failure. So it'll continue to operate off the other one, but it'll continue to scroll through and say, hey, listen, you got a problem with temperature sensor number 1 or temperature sensor number 2. Which, by the way, sensor number 1 is the one in the coil, and sensor number 2 is the one out here. I'll mark that in case it's not. I'll mark that on the wiring diagram. Finishing our thoughts here. FC1, that's your fan contactor. LC1's your lighting contactor. We discussed these 2 guys here as your alarm contactors. CR3 is what energizes this guy up here. So it literally is normally energized along with the personal emergency alarm. That's the way things are done in industry is if the personal emergency alarm is not energized, or it's energized if it's not operational. As soon as you de-energize it, everything goes crazy. It's low voltage, by the way. It's 24 VDC. So, these are fuses. The 128 is actually the door heater fuse. 107, 105, those are disconnects for your solenoids. So you literally could service a solenoid by just pulling those fuses. So if I pull that, you can see this is the fuse. It's a little GMAC style fuse. Pops right out of there. There's a fuse replacement chart right here. It tells you exactly what size that fuse should be. 10 years ago, you couldn't find these fuses anywhere. Now they're everywhere. Home Depot carries loads of them, so they're not a big deal. You just stick it back in there, pop it in place. There it is. 103 is actually the COM in the PLC. We protect the output of the PLC with the COMs and a fuse here. And then 221 is actually for the operator interface. That kills the low voltage, the operator interface. So if something happens to it, we try not to burn things out. So we've got a lot of protection between the breakers and the fuses. Everything is protected really well. Talked about the 24-volt power supply. The PLC and the operator interface are both 24 VDC. And that's where they get their power source, power supply. This little guy right here is what we call the backup temperature. In programmable logic, we know if we've lost the analog input card, which is this guy right here. So if either both your RTDs go down or your analog input card goes down, as opposed to, it's going to tell you, it's going to go into alarm, and the interface or the status line is going to say, hey, you got big problems. But we continue to keep the room below 8 degrees with the backup alarm. We'll actually energize the fans and the liquid solenoid, and bring the room down to 4 degrees, and we'll let it rise to 7, and we'll just continue to cycle it that way. To keep the room until you guys have a chance to find out what the problem is, or we have a chance to find out what the problem is and get it fixed. So all your RTDs actually wire into the analog input card, and they tell the PLC what's going on. Okay. Any questions about that?
So what types of alarms will this give on a contact closure?
That's a great question. We alarm, and this will be in your turnover package. We'll alarm if you lose water.
Okay.
We'll alarm on high temperature, low temperature. If somebody hits the personal emergency alarm, you'll get an alarm out of it for that reason. And if you'd like, we can separate alarms for you. If you say, well, let's do that on one, and a general alarm on the other. However you like to do it, if you let us know, we can help you to get that done. Those are the 4 main things. If you lose your analog input card, it'll give you that's considered a catastrophic alarm. The status line tells us whether the system's okay. If we go into an alarm situation, it'll actually register on the status line. We're about to go on a low temperature alarm here. It's so crazy, like open the door. This will tell us if we're about to go into low temperature or high temperature alarm. But we have a delay period. We'll talk about, I'll show you how that's set up. But a lot of people go in, open this thing up, spend some time going in and out. The room will warm up. It'll go into alarm, as soon as it gets to whatever it's set up, say 8 degrees. You guys are called out. By then the door's closed and it's back down to temperature. The rule just happened. Somebody left the door open. So we have a delay period that we've built into these things. It's adjustable. If you have a nuisance alarm, and it's usually a high temperature, you just increase the delay period. It beats actually spreading out the high temperature, because what happens is if you actually have a high temperature issue, now you just make the problem even worse. Lights, no more switches. We do it virtually right on the control console. By doing that, we can also give you the opportunity to turn it off if they're not getting turned off. Real-time temperature and real-time set point. If you change the set point, it'll register right there as well. Temperature trending, we don't have a chart recorder on this, so we have a temperature trend chart.
Now,
It's not trending yet.
You had the set points on there at 4.
Mm-hmm.
Before you opened the door, it was down to 1.
I don't know. We'll have to check it. See, we just fired it up this morning. We gassed it last night, fired it up this morning.
Okay, so
We'll figure it out and get that thing fixed up. We have to actually set up the AURC. That's what we did before we left. It's probably part of the problem. R.W. Smith, that's our gratuitous advertisement page, but that's also, and there's some important numbers on it. You see the 8555? That's the keys to the kingdom. You notice it also just up there for 8 seconds. Hit the setup. That's the password. That's how you get in to make any changes or adjustments. Okay. Control setup. You have your temperature set point. We talked about 4 degrees. If you wanted, say, 5 degrees, if I said I want 415, 5.0, and you hit enter. Turn the main screen. See, now it wants to maintain 5 degrees. Let me go over that real so you can tell. Most screens are going to change this way. You can touch buttons all day long, nothing happens. You have to activate the number, and you do that by pressing it. You notice it turns to blue. That means it's now a volatile number. So you can be changed. You make it 4.0, and still nothing's happened. You have to enter that into the memory. Boom, turns back to black. That is now the value of your set point. Okay. Almost all screens are going to be that way. Now, any screen set up, there's 1 or 2 exceptions. We'll cross those in a second. Cooling hysteresis and hot gas hysteresis, that's how we control the solenoid valves. Cooling obviously is for liquid, and hot gas is the hot gas valve. May operate a little different than what you might think. At set point, we consider that good. So we don't stop things at set point like we would a regular refrigerator. But on the cooling side, if it gets 0.2 of a degree, or the way it's set up now, if it gets 0.2 of a degree below set point, that's when we take out the hot gas or the liquid line solenoid valve. Okay, so it doesn't go off at set point. It has to go a little bit below set point. What we want to do is maintain set point, and if you stop at set point, then it's just you're always going to have a rising characteristic to the room. So you can set that up to about 1 degree and down to 0.1. Hot gas, this our control set it up to 0.3, but it works the same way. Instead of stopping at set point, it has to get 0.3 degree above set point before we take out the hot gas valve. So if everything's working right, you're hovering right around set point, both hot gas and liquid are operating at the same time, both valves are open at the same time, you're feeding gas and everything's working. That make sense? Mm-hmm. And so we put a little button in here called the get out of jail free card. That's that yellow one down the bottom. If you're in there making some changes and don't know where you're at, if you hit that, that plugs all the original settings that we put in back into it. We set that up because when we initiate a new download, we have to put the program values back in it. So instead of going through the whole thing, we just put one button in there to do it all at one time. I thought that'd be kind of a nice little feature for you guys as well. All screens basically, the top part tells you what the screen purpose is, and there's a return to the main screen. So if you hit this, that goes all the way back to the main screen. Then you have a back button that takes you back one screen from where you came. Okay. So go back one. Alarm log. We'll go ahead and cover this one because I usually wait till last and I'm out of gas by then. This is the log that's going to keep all the things that happen in this, including if somebody turns the fan switch off, it'll tell you that's happened. All the alarm situations, and the personal emergency alarm. If somebody hit, like we just did a few minutes ago, we hit the personal emergency alarm, it actually will log that. It'll tell you that you had an issue. If it's in blue, that means it's cleared. You can also tell because underneath the cleared there's some writing. But it gives you the month, the day, and the time that it actually occurred. What the occurrence was, in this case it's personal emergency, and then when it cleared, we pulled it pretty quickly. So about in the same time frame, that thing came back out of alarm. If somebody said, I think something happened, but it's running fine the next day, you can go back to the alarm log and take a look and say, well, you had a water failure last night at 2 o'clock in the morning. And it didn't come back down until 6. I mean, it was a 4-hour period there when the unit went into high temp. If it goes into high temp, it'll also log the high temp as well. You can have, I think, up to 1,000 logs on this this alarm, which is quite a few. If you have more than a screen's worth, you could select it and then you can scroll down. So the most recent will be at the top. And you can scroll down to the older ones. Like in this case, you say, okay, well that's an old one, I don't need to deal with that. You can delete it. And you can delete them one at a time. Or if you say, there's just a bunch of old stuff on here I don't care about, you can delete all of them. This will also log if you have an RTD, just even one RTD. If one RTD goes out, this will give that an issue. Any question about that? This screen's a little different, a little more like Windows. We have the X at the top, and that's how you get out of that one. It's called a pop-up screen. Config overview. We built this screen just so we could take a quick look at how everything was set up. Your temperature alarms, which we haven't really discussed at length yet. Your 2 hysteresis, your hot gas and liquid hysteresis, and then your defrost, how long your defrost duration is, and we'll talk about that in a second. But that's the purpose of this screen, is just so you can take a quick look at that. Talk about defrost. In most 4-degree rooms, I mean it's almost 40 degrees Fahrenheit, you don't need to defrost, but in a room that's built to maintain such a tight temperature tolerance, it has no time to defrost. And we're running the compressor all the time. We're keeping, theoretically speaking, if you're running a room at 39 degrees, your saturated suction, your coil is 29 degrees, which is below freezing. So you're going to develop frost in there at some point if everything's working the way it's supposed to. So the controller's set up at midnight to go into defrost, and we basically give it 10 minutes, and that's sort of what we factory set. If you're having a frosting problem, increase that. Just send that up to whatever it needs to be. It should only need 1 a day, unless it's one that has a whole lot of traffic like that. We've had them like this, we have a lot of traffic, you don't have too many problems. Part of that reason is because of the way they're set up, you have an air screen that covers the door, so there's not a lot of moisture that's allowed to get into the room. Plus Utah's a pretty dry place. You have this button up here that gives you the opportunity to put it in manual defrost. You can hit that, put it in manual defrost. You can hit it again and actually take it out of defrost. Okay. So if you do have a frosting issue, hit that, run it through the frosting. This is one of those that I was going to tell you about, where it actually has a slightly different setup screen. All you would do to make a change would say, I want 12 minutes, and enter it. Okay, that's more of a pop-up setup screen. That's just because there's just not enough room to put the information in there I want to put on it.
What is the defrost? Is it a...
Good question. I'm sorry I didn't cover that. No, we don't use hot gas. We literally just shut off the refrigeration and let the air in the room do it.
Oh,
Yeah. It's just,
no heater, nothing?
no heaters, really not required. You're running a 40-degree room. There's not much reason to actually heat anything up. The problem with heating the coil up is then you got to cool it back off, and you got delays and all these things, and it's an overcomplicated system that doesn't ever need there. And that's what we found out in the last 25 years anyway. The alarms, we'll hit the alarms real quick while we're at it. They're both going to look the same. Alarms are handled as deviation from set point. So if you change the set point, if you're okay with the deviation, you don't have to change the alarms. So essentially what we're telling you, anything over 3 degrees above set point is going to initiate a high temperature. Okay? If you say, if we're set at 4 degrees, if you get to 7.1 degrees, it's going to register on the status line on the main screen high temperature. Okay? You've got a high temperature situation, but you haven't disengaged or de-energized your alarm, remote alarms. You haven't caused this guy here to go off. None of that's happened until after the delay period. So if it's hovering right there and it's going in and out of alarm, it has to be a full, if it's set at 10 minutes, a full 10-minute delay period before anything actually happens. We don't take anything out. We don't start taking fans and heaters and all that stuff out. It just, there's just no good way to, because if you did that, you'd have to reset the ring back, because it's not going to get cold on its own, if you do that sort of thing. So we leave it to set itself back up, because usually what happens in a high temperature alarm, it's a power issue or something. Once that's restored, it's restored. I'm probably stepping on my tongue here a little bit. You don't have to acknowledge any alarms. You don't have to do anything. It'll reset itself regardless of what the issue is. Okay, you might have to fix something, but there's no resetting or acknowledging like some systems will do. The delay, there's your delay time, 10 minutes. We have several screens that'll take you to what's called mute time. And you can see it's mute, and this is another one where you would actually set it up to mute time that way. What mute time does, let's go back to the main screen. If you go into alarm, the typical alarm on this, not the PEA, but the typical alarm is a 1 second pulse. So you have that 95 dB, 1 second on, 1 second on, 1 second on, 1 second on. It's almost manageable. It's loud, but it's almost manageable. This little button will light up red and it'll tell you you're in alarm. Okay? Press the mute. You touch that, you can hear it's an active alarm. It'll actually turn that off, put it in the state it is now, and turn off the audible alarm. Mute time is you have 90 minutes to fix that problem. Otherwise, you have to come back in and touch the button again, because your horn's going to drive somebody crazy. That make sense? Low temperature alarm is going to look exactly like that. Your deviation, delay. Now, low temperature, we do things a little bit different. If you go into low temperature, once you hit a low temperature condition, we actually kill the fans. Most researchers that we run into tell us, if it gets a little warm, we know what happens. If we freeze stuff, we're just out of luck. We don't know what happens. And even worse, this room doesn't have it, but a lot of rooms are equipped with sinks and faucets. And the worst thing you can do is, in those goosenecks, is to freeze those things, because freezing's not the problem, it's the defrosting. And now we got a geyser in the room, and that's always a problem. So we'll actually shut the fans off and cycle the fans on and off with temperature. Once it comes back up to 4 degrees or comes out of its low temperature condition, resets itself, and then the fans will come back on. People have called us and I don't know what the problem is, but the temperature's fine, but the fans keep cycling on and off. So we probably have a problem with solenoid or something like that that's causing something. You go to set time. Let's go back here. That's the time that the PLC thinks it is. There we go. Have a high temperature condition. Press that. So there's your high temperature condition. Now it'll take, because of all the alarms on it and issues that can be on the status line, it may take a little time to rotate through. But this will come up pretty quick on the first shot. If you've got more than one thing like this, and it was a water failure that was causing the issue, it may take 10 or 15 seconds to actually rotate through that, tell you it's a water failure. So if you say there's a problem with it, may ask you to just sit and watch that for a second, see if it scrolls through and tells you something other than just high temperature. Sometimes it will. We were talking about setting the time. So this time is what the time the PLC is. So really the most important thing that this thing does is the defrost. So it knows, at 12 o'clock it goes in defrost. If you want to change that, daylight savings, do they do daylight savings in Utah? If you want to change it for that for any reason, it's not really that important in the overall operation room, but if you wanted to keep it clean, the hour and minute, you would set up the hour, say it's 12 o'clock. Let's say it's 03. Okay? We'll go back and you see nothing's changed here. There are special registers in the PLC that have to get that time to make it actual time. So we have this big button here that says press after change. What that does is that forces these numbers into those special registers. So we go back to the main screen, you see you've changed your time. Guys are saying, yeah, I'm going to come and do that all the time, Phil. Calibration. These RTDs calibrate just like Honeywell or any other controller out there. It's an offset calibration. And you have two of them. You have number one, the one that's in the coil, and number two, the one that's out here. We found the best way to do this is to shut the room off, shut the fans off, just shut the room down, put a little switch on top if you want, and then use your flute meter, whatever you're using to calibrate that. Get it near the RTD and then set it up that way. This is the temperature that the RTD thinks it is. And this is your offset calibration. So if we stuck our fluke in there and it said, no, it's 11.9. And we would hit that and go 0.4 and enter. And now it's 11.9. Simple as that. A lot easier than Honeywell, I can tell you that. Same thing in reverse. If they thought it was 10.7, you go minus 0.7, enter, and now it's 10.7. Okay. That's simple. So we'll check those things, make sure they're close. We generally don't make it. They're within a couple tenths of a degree. We don't make adjustments. The analog input card, 16-bit, and they're very good at what they do these days. You shouldn't have to mess with that too much, but if you have a calibration sequence that you like to do on equipment, you want to put that on your schedule. But that's how tough it is. Just remember that one is up here and two is in here. And two, same thing. Again, because it's the downstream, it's the colder temperature. The other one's getting this air coming right in here. Last but not least is the override. This is another one of those screens that we installed for our guys to be able to check circuitry. We could come in and actually energize circuitry and figure out whether or not we were on the right circuit. And we decided to leave it in because it's a good troubleshooting tool. What you can see, that's the place we missed, Steve. We have still a dehumidifier showing in here. We'll get rid of that. What you can see is it's calling for the liquid line solenoid and the fans. In industrial speak, red is unsafe or on, rotating, hot, whatever. So we sort of use the same mentality here. So if it's red, it means it's energized. If it's green, it's safe or it's off. So red means these guys at the bottom just tell us whether or not the output at the PLC is sending a signal. Okay, so you can very quickly come in here and ascertain whether it's something that's the PLC is the problem or it's something downstream if you're having a circuit issue. What we did is we gave this the ability to override that. And now we have all kinds of stuff that says don't leave it in override. But if we wanted a hot gas valve to open, that little switch you heard, the hot gas valve open. Okay? Notice it stays red. Now that thing will stay. You can leave this and that thing will stay just like it is. But we put a little thing on the front that says, come back. Don't leave it like this, please. The problem being, if one of those, if something is left on and shouldn't be, now your automatic control is going to on control things. So that's why this is over there. That make sense?
Yeah.
Okay. Now, if you don't want to go all the way back and turn that back off, you literally can kill power to the thing and turn it back on. That resets it as well. Test your horn.
A power interruption resets all your overrides?
Yeah, these overrides here, just these overrides. There's not a lot to do. I mean, you've got your solenoids, your fans, and your horn. This won't be there when we're done. We didn't realize we left that on the screen. That shouldn't be there because you don't have a dehumidifier. And that pretty much is it. Have I missed anything?
What if the power goes out? Do you have to do anything if the power goes out?
No, there's nothing for restart. No, there's nothing you have to do. There's no resetting or.
So the only time the compressor on this shuts off is defrost.
Defrost, exactly.
It's running 24/7.
Yeah.
Wow.
Runs when you're in hot gas, depending upon just how cold or how warm the room is. You literally that's how you get your power supplies.
Now, we don't know what they're going to use this for, so is this designed to be run 365 days a year, or will they run it just a week at a time? You know?
Yeah, it's designed to run from now on. But if they wanted to shut it off, again, the best way to do that is just to kill that switch. If they just said, let's shut it off. Everything else, your lights continue to work. You don't have to deal with your lawn, your automated lawn. One thing I failed to mention, the door heat. One of the problems we had early on was the door heat. You can feel the door heat around here. You leave the power to it, but the door heat, would get too hot just because there's no cooling going on the inside. We actually run the door heat circuit across the fan contactor. That's what this guy here is. So if the fans aren't working, it kills the door heat. So if you're trying to troubleshoot the door heat with the fans off, you're going to have problems. Yeah, they're real run. It's just you want a little warmth there. So. To answer your question, no, there's no reset, power failure, startup, nothing. Just if you're gonna shut it down though, I'd recommend if you have to just kill the disconnect, you can do that because it kills the solenoids because it's on a separate circuit. It's not gonna kill us, but otherwise, the best thing to do is to kill that switch inside.
How come they don't regulate the temperature with the on and off of the thermostat versus turning the gas off and on?
Good question. With typical refrigeration, you're either at 100% refrigeration or none at all. So you have real wide spikes in operation. By keeping the compressor running all the time, you have the ability to actually eliminate the high and lows in those spikes. And plus, they found one of the biggest sources of problems with compressors is just that they're starting and stopping. So if somebody wanted to, tighten up on just an on-off system, if they wanted to tighten up the operation on it, they would just make it come on and off more often. In addition to that, it costs a lot of money to start the compressor. Once it gets running, it's not going to do. But you have those starting spikes that are enormous. You're starting something that's already under a load. So just over the years, we have very few compressor failures because they run all the time. They're not starting and stopping. Almost no problems with the electrical components of them.
Yeah, because they're always closed.
Because they're not arcing and sparking all the time. Good question. Anything else? Come on, I had to forget something. I guess that's it.